Ever wondered what really happens when you write JavaScript? You type friendly code, functions, objects, arrays, and equality checks. But the CPU does not understand JavaScript. It only understands tiny low-level instructions. Between those two worlds sits the JavaScript engine, like Google's V8. Think of it as a virtual machine. It reads your JavaScript, studies how it behaves, and turns it into work the CPU can execute. At the bottom, the CPU is simple but extremely fast. It moves data between memory and registers. A program counter decides the next instruction. The arithmetic logic unit performs calculations. Over and over, the CPU loads data, compares values, stores results, and jumps to the next instruction. JavaScript feels high-level, but the machine is always doing these tiny steps. When you call a JavaScript function, the machine does not see a magical function. It sees something closer to a subroutine. Save the current state, jump to another section of code, pass data, then return. Modern JavaScript engines try to reduce that cost. If a function is called again and again, the engine may inline it. Instead of jumping away, it copies the useful work into the hot path. The engine also watches your objects. If objects are created with the same properties in the same order, they share a shape, sometimes called a hidden class. Stable shapes make property access faster. This leads to inline caching. When your code reads user.name, the engine remembers where name was found. If future objects look the same, the engine uses that shortcut. But JavaScript is dynamic. If objects keep changing shape, or the same code sees many different types, the engine loses confidence. Optimized code can be thrown away. This is called deoptimization. There are also small performance traps. Triple equals is usually easier to optimize than double equals because there is no type coercion. Holy arrays, repeated object copying, and -0 can also create hard cases. The point is not to fear JavaScript. The point is to build a mental model. Measure first. Optimize hot paths. Keep object shapes consistent. Avoid unnecessary type changes. And remember Amdahl's law, speeding up code that barely runs will barely change the app. Once you understand the layers, JavaScript performance stops feeling mysterious.